Hey everybody, Doc here. We're on section 2. Once again, we are reviewing. So we have exponents and radicals today, integer exponents, rules for working with exponents, scientific notation, radicals, rational exponents, and rationalizing the denominator. Integer exponents is when we have a product that, let's say, for instance, 5. So we have 5 times 5 times 5. That would be written 5 to the third. So this general definition is a, any base to the nth power would be a times that n number of times. A is called the base, n is called the exponent. So if we have 1/2 to the 5th, that would be 1, 2, 3, 4, 5 times. Multiply the tops, multiply the bottoms, and we will have 1/32. -3 to the 4th power would be -3 times itself 4 times. You have an even number of exponents, so it's going to end up being positive 81. If the negative is on the outside and not in parentheses, then you do not take it to the exponent. So the negative hangs out here, and you just take 3 to the 4th power, and in this case it would be -81. A cannot equal 0, any real number that is n, positive integer. If you have a, any base at all to the 0 power, it's equal to 1, other than 0. So any base at all to the 0 power is equal to 1. And if you have a to the negative n power, so to a negative integer, that is actually a directional exponent telling you that that value will go on to the bottom, a to the n number of times. So a to the negative n would be 1/a to the n. This is all to the 0 power, so that one is 1. If I have x to the -1, I'm going to place that x value on the bottom and have 1/x. -2 to the -3, this one is a directional, so that tells you it will go on the bottom of the fraction, and then you take your -2 to the 3rd power. So we'll have 1/8. And you can leave the negative on the bottom. You could put it in the middle. You could actually put it on the top if you like. All right, rules of exponents. So here we have the laws of exponents that I'm sure you studied in high school. So if you have the same base and then it's m and n, you add your exponent. So same base, you add your exponent. So 3 to the 2nd times 3 to the 5th is 3 to the 7th. Here, if you have a to the m over a to the n, then you are subtracting your exponents. If you have a base to a power and then it's raised to another power, then you're multiplying the exponents. Hopefully these are all looking very familiar to you. So we have AB on the inside to the n power. You're going to take that exponent to each one. And if it is in quotient form, again, you take the exponent to the numerator and the denominator. So here we have a common problem that you'll see with laws of exponents. You want to do your exponent on the outside first. So you're going to take this to be 3 to the 3rd, 3 times 3 times 3, which is 27, then a to the 3rd, and then b to the 12th. They didn't multiply. Go ahead and multiply these two here to get your b to the 12th. Simplifying that, again, this is 27. Okay, this is what we just said here. And now we're going to multiply our two numbers. So we'll get 54, a to the 3rd, and a to the 3rd. You're going to add the exponents, a to the 6th, b to the 2nd times b to the 12th. You get b to the 14th power. So 54a to the 6th, b to the 14th. The second example, we're again want to go outside and work our way in. So we're going to take this cube into both of these. So we have x cubed, y cubed. And then when we take our 4 in, remember it's a power raised to a power. So here you're multiplying. So y to the 8th, x to the 4th, z to the 4th. Now I can multiply my tops, so I have x cubed and x to the 4th, which will give me x to the 7th. My y to the 8th is on the top. I'll leave that there for a moment, but then I notice that I have a y to the 3rd on the bottom, so these two I will subtract, and I will have y to the 8th and y over y to the 3rd. Subtracting will give me y to the 5th. So here they actually organize it for you one more time so you can see it a little clearer. And we have x to the 7th, y to the 5th over z to the 4th. Now we also have a couple other laws that aren't as common, but if you have a fraction and it is raised to the negative power, you can just flip it over and make it to the positive power. This is real handy. So if you have 3/4 to the negative 2, you want to flip that over and make that 4/3 to the 2nd, and then simplify it from there, of course. Here we also have where we have to the negative n on the top, negative m on the bottom. We're just going to reverse these two, put this on the bottom, put this on the top, and then that way we will have 4 to the 5th on the top, 3 to the 2nd on the bottom, and of course you would simplify it more from there. Now, a lot of times people will do these different ways. Here they say eliminate the negative exponents and simplify. I think that is the easiest way to do it. So I'm going to move my t to the negative 4 on the bottom and make it t to the positive 4. And my s to the negative 2 on the bottom here and bring it up and make it s squared and go from there to simplify. So here you have it again. Put the t to the 4 on the bottom, s squared on the top. And now I can combine my s's by adding my exponents and my t's by adding my exponents on the bottom. And of course, I'm going to want to take 6 divided by 2, which is 3. So here we go. We have our 3, s to the 3rd, t to the 6th. Now this is a negative exponent here, so we're going to flip the inside over, and then we will bring the squared on the inside, making that 9z to the 6th y over y to the 2nd. Scientific notation. Now scientific notation is one of those topics that comes up depending on what you're working on. If you're in science, you often use scientific notation because we have really, really big numbers and sometimes really, really small numbers. So let's review that. Here, if I have x times 10 to the n, where n is a integer. So n is an integer. If it's positive, it's directional. You're going to move your decimal to your right. If it's negative, you're going to move your decimal to the left. So notice here we have 4 times 10 to the 13th. So you're going to start after the 4, and then you're going to count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So then you end up getting this large number. Notice here it is negative. So as I said, you start at the decimal. Decimal is here. If it's a whole number, the decimal is at the end of the number. And we're going to go backwards, 24. So we go 1. And then from this point, we're going to be adding zeros. So we're going to be adding 23 more zeros. putting a decimal point, and we always put a decimal point in front of the decimal here just for it looks better. And there you go. So right in scientific notation, we can see this first one. You're going to want to bring it back to here. So I'm going to have 1, 2, 3, 4. So it's going to be 5.692 times 10 to the 4th. Here, I have to go back 1, 2, 3, 4, 5. So I'm going to have 9.3 times 10 to the negative 5. Okay, so there we go. And there's the bottom one. Radicals. So here, this symbol is a radical, meaning the root of. Often we call it square root if there's a number under it, because there is a 2 that is understood to be here. So this means b squared would equal that a if we have the numbers there, because then this is going to be a square root. Square roots are special cases of the nth root. And so if we look here and we see this radical with an n here, that number is going to be a number other than 2, because 2 is always understood if it's not there. And this would mean b to the n would equal a. Here are some properties. Now you'll notice these properties are very similar to the properties of exponents, and that's because roots are actually exponents. So here I have AB all under the square root, or not the square root, the nth root of AB means you'll take the nth root of A and the nth root of B. So here are some examples over here. It shows you how you can break this up to solve it. Here I have the cube root of x to the 4th. Now, since this is a cube root, I need to have at least 3 for 1 to come out. So I can group them in 3s underneath. This tells me that 1x will come out on the outside, and I will still have 1x left over on the inside. Again, if we have 81, the 4th root of 81, x to the 8th, y to the 4th, we can split it up. We can break this one into 4, so put x to the 4th and x to the 4th. Or you can put, here instead of doing that, they said x squared to the 4th power. You can do it that way as well. Why did they put an absolute value of y here? Because they want to indicate that it's the positive value. And we would have 3x squared y. Now normally you wouldn't put the absolute value here. When you're doing these problems, you would just put 3x squared y, and it would be understood that it is a positive value. Okay, combining radicals. When you combine radicals, they have to have the same base. So here, obviously, this is 32. This is 200. They are not the same. However, if I break this 32 down to 16 times 2, I will get 4 square roots of 2. And if I break this down to 100 times 2, I will get 10 square roots of 2. See here, this will be 4 square root of 2, 10 square root of 2. Now I have 4 times the square root of 2 plus 10 times the square root of 2. This is now like terms. Just like when you are adding like terms in your algebra expressions, radicals are treated the same way. You want to make sure you have the same base, the same root, and if you do, then you just add the front and you will get 14 square root of 2. Here I have the square root of 25b. I can see right here that I can pull out the square root of 25. That will give me 5. I also have b cubed under the square root, so I can group them in 2's and put my b squared separate and still have the square root of b. Simplify it, and now I have the same radical here. So this would be 5 minus b in parentheses times the square root of b. Rational exponents. So remember, rational means it can be written as a fraction. So here I have a to the 1 over n raised to the n power. If I multiply these two, I will get a to the first. So by definition, a to the 1 over n is equal to the nth root of a. If I have a to the m over n, the bottom number is your roots, and then it'll be raised to the m power. You could actually put this on the outside, or if it benefits you, you can put the m on the inside. So this is a choice. It doesn't matter what order you do it in. You might want to take the nth root of a first and then raise it to the m power, or you might want to take a to the m, and that might help you break it down when you have the nth root. Okay, laws of exponents here say same base, I add the exponents, so I would just get 8/3. Here again, I'm going to add my exponents on the top, so I will have 9/5 on the top over 3/5 on the bottom, and that means I would subtract the 3/5. So I'll have 2/5 plus 7/5 minus 3/5, and that'll be a to the 6/5. Now, I usually teach this another way. I'm going to show you one thing that I do often here is, since I have a to the 6/5, we know that 6/5 is 1 and 1/5, right? And there's a reason that I'm doing it this way, because this 1 value here tells me how many a's I'm going to have on the outside of the radical. So I would have an a on the outside, and then this is the actual root. So this would be my 5th. Sorry for the messy drawing, still getting the hang of this. 5th root of a. So this part is my 1/5, and this is my 1. So this is another way to simplify these, and I actually used this when I was doing the radicals earlier. I don't know if you noticed, I was pausing just a little bit because I was trying to debate on whether or not to show that to you then or wait till now. Okay, so we have 3/2 on the outside, so that means I have to take my 2 to the 3/2 first. Then I'm going to multiply 3 times my 3/2 and then 4 times my 3/2 here. So I have the square root of 2 to the 3rd, a to the third, again, 3/2, b to the fourth times 3/2, and I'm going to go ahead and do that multiplication, and I would have this. Now, once again, from what I just showed you before, I want to take this a to the 9/2 and take a look at that, because if I make that a mixed number, that would be a to the 4 and 1/2. Now, this 1/2 is a square root, and this is a square root. So that would tell me that I have 2a to the 4th on the outside. Also, that b to the 6th will be out there. And then inside the square root, I have a square root of 2, but I also have the square root of a. So this would actually be the better final form. Let's see if they do that. Nope, they didn't. So good thing I showed you. Okay, so here we have 2x to the 3/4, y to the 1/3 on the bottom. We're going to take our value in. Then we're going to take a look at y to the 4th over x to the negative 1/2. Now keep in mind, x to the negative 1/2, you're going to bring that to the top and make it x to the positive 1/2. They went ahead and did that right here. Simplified a little more, 2 to the 3rd is now 8. You have x to the 9/4 over y. You still have a y to the 4th, x to the 1/2. You're going to simplify this, make this y cubed. And then you have x to the 9/4 and x to the 1/2. Well, if you have x to the 9/4, and then you're going to take x to the 1/2, you're going to add those exponents. So I'm going to make that 1/2 2/4 to make it a common denominator. My 2's looking a little weak, sorry. Let me go back up here and fix it. Okay, and so this would be my x to the 11/4. Now, let's see what their next step was. Yep, x to the 11/4. They didn't explain it, but this is how you would combine these two. And then you would have y to the 3rd by subtracting the y's. Now, depending on what form you need to leave it in, you might leave it like this. You might change it to a radical. That all depends on what you're going to do next with this item. Rationalizing the denominator. So rationalizing the denominator, we don't like to leave radicals on the bottom of the denominator. Sometimes we will if we're going to continue to do some more calculations with it. But in general, for a final answer, it's not good to have a radical on the bottom of a fraction. So in order to get it off of the bottom of the fraction, you're going to want to multiply it by a form of 1 that will allow for you to get the radical off the bottom. That form of 1 will be whatever it takes to multiply this by so that you can get a by itself. So if I have the square root of a, I need another square root of a so that when I multiply them together, I will have the square root of a squared, and that square root of a squared will just give me a. Okay, so that's how that works. And now we will have the radical on the top with the square root of a, which is fine. We just don't want it at the bottom. All right, so when we take a look at, in general, taking the denominator in the form of the nth root of a to the m. Going to multiply the numerator and the denominator by whatever this value is minus m. Now this looks a little confusing, but we'll look at an example. Basically, whatever this is, these two need to add up to be n. Okay, so let's take a look at hopefully an examples here next. Yes, so if I have the square root of 3, I'm going to multiply it by the square root of 3 over the square root of 3, because that'll give me the square root of 3 squared, which will just give me 3. Here, I already have 2 x's. I need 3. So I'm just going to multiply it by the cube root of 1 more, because these two together, when you add them, have to equal the root out here. Here I have a 7th root. Okay, so 1 to any power is 1, so I can simplify that right away. Now, think about it. How many more do you think we would need to get this 7th root of a squared out? Well, these have to add up to 7, so I need another a to the 5th. So I'm going to multiply by 7a to the 5th over 7a to the 5th. That will give me 7th root of a to the 7th, which will give me 1. See, now this is just 1, so it's now a to the, just a to the first power on the bottom, and the 7th root of a to the 5th is still left on the top.